In this video, we're going to be talking about symmetry, if that's not already too obvious. There are three types of symmetries that we have. First, we have line symmetry, then we have point symmetry, and of course we have rotational symmetry. Let's start with line symmetry. What makes a figure line symmetrical? Well, if it has a mirror image somewhere along, I sort of think of it as like a folding spot. I can fold that triangle along that spot, and what I have essentially are two mirror images of each other. The blue piece and the green piece are identical and could fold over each other. So if a figure has line symmetry, it can be mapped onto itself across a reflection or a line. And we've talked about reflections, so that should make sense. Next, we move on to point symmetry. A figure has point symmetry, right, if the figure is mapped onto itself by rotating the figure 180 degrees about the center point. So over here we're looking at that letter N, and we're saying that, hey, look, if you flip N upside down, it looks the same. So I think I've added a couple of things right here and here that you don't have in your notes. So go ahead and press pause and add those into your notes. Press pause now. Okay, now that we have that squared away in our notes, let's take a look at this N. Now, I've traced over it with some red ink, so if I just kind of grab this and flip it around so that it's upside down, isn't it the same object? The answer to that is a resounding yes. So since it is the same upside down, it has point symmetry. Now, is there any way that I can draw a line through that N and have it fold over itself? So what if I were to draw a line right there? Would that fold over onto itself? And the answer to that is no. This diagonal piece really is what's messing us up. The bottom part's going to overlap into a space here, and the upper part's going to overlap into a space here. So it doesn't have line symmetry, but it does have point symmetry. All right, moving on to rotational symmetry. As it states, a figure has rotational symmetry if the figure is mapped onto itself, right, by rotating the figure less than all the way around. So if you rotated it 25 degrees, 90 degrees, 180 degrees, 270 degrees, think about it as a pinwheel. So this figure right here, if you were to rotate it around just a little bit, it would map onto itself. Now, if a figure has rotational symmetry, there's a good chance it may have point symmetry. But in the opposite direction, if it does have point symmetry, it guaranteed has rotational symmetry. At least if you spin it 180 degrees, it definitely has that portion of the rotational symmetry. So rotational doesn't imply point, but point definitely implies rotational. And we'll tinker around with this a little bit more in future slides. So first, we have this six-sided figure. And a six-sided figure is a hexagon. And this happens to be a regular hexagon because all of the angles and sides are the same. So we're taking a look at our regular hexagon here. And I'm wondering, does this have line symmetry? Well, I think if you draw a line straight down this way, the figure would map over itself, and if you draw a line down this way, the figure would map onto itself. So it definitely has line symmetry. So let's start there. Now I've erased my lines, but I would encourage you to draw the lines in for line symmetry to see if you actually can show where it would fold. Now the next one, I've traced over the hexagon, and the question is, if I take this and spin it 180 degrees, is that the same thing? Now you may want to use the patty paper, and all you got to do is just ask for that in class so that you can trace it and spin it around. And since I spun it around and I still have an identical figure, I'm going to say that yes, this has point symmetry. Now since it has point symmetry, if I could rotate it around 180 degrees, it definitely has at least one version of rotational symmetry. And it actually, if I take it, I'm just going to move it around, I can move it 6 times or I should say 5 times until I get all the way around, and then I would have the exact same figure each and every time I spun it around just a little bit. Now, since I have all 3 versions, none is obviously not an option. Let's move on to another example. Next we have a parallelogram. That's our 4-sided polygon. Now a lot of students say, well, hey, there's, the top side is the same length as the bottom side, and perhaps maybe we have some line symmetry, but we don't. If you draw a line diagonally that way, this corner here is not going to map itself to this one here. They don't match up perfectly. And if you try to match the corners up, the sides won't match perfectly. And that goes for both diagonals. So no dice on the diagonal lines. If you go vertically right here, again, the slant here won't match up with this slant over there. So that's not going to work. The bottom line here is there is no line symmetry. How about point symmetry? Again, you'll want to grab your patty paper and trace it if you can't see it naturally. There's no harm in doing that. So essentially what I'm doing is I'm using my quasi patty paper to spin it 180 degrees. I got that. So yes, whoops, I have point symmetry. And as soon as I have point, I definitely have rotational. I have the 180 degree rotation. And that's the only rotational symmetry that this has, only 180 degrees. Before on the regular hexagon, I had more than that. But I only need one, the 180 degree, to have that rotational. So I have point, and automatically I have rotational. Moving on. Now we have a basic star. Does this have line symmetry? Well, I believe that if I draw a vertical line right there, this leg's going to match up nicely with that one. This one's going to match up nicely with that one. And the top piece will match up with itself. So all I need is one line of symmetry to be there. But of course, there are many others as I draw them in. So I think that's enough to prove our point for line symmetry. Let's try point. Go ahead and press pause and trace your figure and decide, can you rotate it 180 degrees? Okay, well, I've traced mine and I've marked the top. Hopefully it'll go with me. And as I bring the top to the bottom, I notice that, 180 degrees doesn't work. So it does not have point symmetry. I can't spin it upside down and have the same figure. But that being said, if I spin it just a little bit less than 180, or even just a little bit less than that, I have some rotational symmetry. So you see, it is possible to have some rotational symmetry without having point symmetry. So we have the rotational. So just going back to that first slide, if we have point is 180 degrees only. If you have point, you automatically have rotational, because rotational means any amount of degree of rotation. But if I don't have the 180, I still need to check for the rotational. So for the star, we're going to have line symmetry and rotational symmetry only. Let's keep going. All right, we got some block lettering, okay, the letter A. And what do you think? Does it have line symmetry? If so, can you draw the line? I think if we draw a vertical line right there, that's going to be the only line of symmetry we have, but we only need one to say that it has line symmetry. Now, hopefully you understand that if you rotate the A upside down, that we obviously do not have the same letter, be an upside down A, and really, this letter is only going to be the letter A if it stands just like it is. So it's only going to have line symmetry, and that's it. Hopefully this is starting to make sense. Let's move on. Number 9 has a little bit of a pinwheel effect going on. Now this one, what do you think about line symmetry? Are you thinking yes, or are you thinking no? If you're thinking yes, what I'd like to know is where in this figure can you fold things over? If you fold it over sort of the x-axis, that horizontal piece is going to fold over to a vertical looking piece. And if you fold it along a y-axis kind of thing, or an x equals line, again, this horizontal looking triangle is going to reflect onto that vertical one. if you go diagonally, what do you think about that? I think that if you fold along that, this piece is going to fold here, this piece is going to fold there. They're not going to line up. Now we have quite a mess here, but obviously we do not have line symmetry. Grab your patty paper, trace the figure, and see if you can trace the whole figure out without crossing over your own line. Trace the whole figure without any lifting of the pencil, just for the fun of it. Not that it has anything to do with this exercise. Okay, so no line symmetry, but what about point? Notice I've marked the top so that I don't lose it as I begin to spin it. And when I spin this thing around 180 degrees, my top, the word top is upside down. Looks like we're pretty good. My tracing's not that great, but we definitely have point. And remember, as soon as we check off point, we know that we have rotational. We know we have at least 180 degrees of symmetry. But what about slightly less than that? So if we rotate it just 90 degrees, it looks like we have it there. So 90, 180, 270, and of course 360 back to the top, which doesn't count as one of the rotations, right? Anything less than 360. So looks like we have three different types of rotational symmetry. So for number 9, we're going to mark off point and rotational. The Queen of Hearts. What do you think? Line symmetry? Hopefully you're saying, no way. If I vertically cut this in half, that queen, or that Q of hearts is going to go right here, and there's nothing matching it. Same here. And if I do it with a horizontal line, this Q hearts is going to go up there, and that Q of hearts is going to go down there. No dice, and also the faces are slightly askew. That's not going to work. There's no diagonal symmetry here. Try folding a rectangle diagonally. Not going to happen. Your piece of paper is a prime example. Can't fold it diagonally and make it match up perfectly. So line symmetry is off the plate. Now, in order for me to demonstrate any other type of symmetry, I'm not going to try to trace all the Queen of Hearts, so I thought I'd bring in a perfect replica over here on the side. I'm just going to mark the top. So onward to point symmetry. As I rotate this thing around 180 degrees, we're looking at it. What do you think? It looks like we have a perfect replica. So it definitely has point. And now what's the rule? You guessed it, rotational automatically. Does it have any other rotational symmetry? If we rotate it this way, no. If we rotate it that way, no. And not sure why this just shrunk down like that, but we'll put everything back the way it was. And say that the Queen of Hearts has point and rotational, but only one version of rotational, which is 180 degrees. This brings us to our last figure. What do you think? Line symmetry? Draw a line there. I don't know, we really mess up this arrow right here, and I think what you're starting to understand is that line symmetry is kind of a tough one. What about 180 degrees? Well, if you think about this, it's like a triangular type figure. Hopefully you realize that as we spin this upside down, that's not really going to happen. And what about rotational symmetry? Well, we're sort of jumping ahead, but let's go grab the patty paper and let's trace this out, then make a decision. And as you realize that I keep referring to that tracing paper because that is really the surefire way of doing this. Until you can really start to trust your instincts, you need to see it first, right? We're going to be visual learners here. Okay, well what I've done is I've brought in my screen capture replica and I have marked the top of the figure, top, and so now we're going to go for that 180 degree spin. So we spin it around, and was that the same figure? We take a look and I say, I don't think so. I think that when we're upside down, the figure looks upside down, not like a duplicate. But if you just push it backwards a little bit here, we have a replica. So if we start from the top, and we just go until we get to this point here, I think we have a replica. This point here, I think we have a replica. So we have at least two other rotationals. So although we don't have point, we definitely have rotational. And that's going to be the only one that we have here. We don't have point because remember, upside down, or 180 degrees, when that figure was upside down, it was not an exact replica. It didn't look horrific, but it doesn't match the original. So that's about it. And what you want to do is now just go through the rest of this handout and answer the rest to the best of your ability. All right? Good luck. See you next video.